Hello everyone and welcome back to another special video in session 2. In the last video, when Lee was setting up the code required to allow us to come into the world at any point and have terrain up underneath our feet, I made the crack about having a mini-map in the world so that we could see where we were at. Not only that, we've also had one of the students in the class put together a very basic mini-map as well. So between videos, I told Lee, "Oh, come on, let's throw a quick mini map together so that we could show people where we were at." And Lee was kind enough to agree. So in this video, while it was something that was thrown together very quickly, Lee is going to demonstrate how to put together a very, very basic mini map. Now, please keep in mind, this is really one of those things where it's almost not even R&D. We're just playing, it's late, and we're capturing this in video format to throw it up for those of you that might not know how to do something like this.
Well, you did give me 20 minutes to develop it.
Oh, I thought it was more like 15, but okay. It
Well,
was, but I was impressed with, well, we'll go with 20 minutes. I was impressed with 20 minutes, the fact that you actually gave me some graphics. I thought you were just going to work with the one that we were using as opposed to making something that looked a little more interesting.
I did it first. Just go, hey, look, see, it's a mini map. It's like, okay, now let me have some fun. I actually spent more time working on the graphic for the mini map than I did for the code for it, so
Okay,
that's
so,
pretty sad. But okay, well, let's get started. We need a mini map. That means we need a class.
okay.
So let's go ahead and right click, go to add, new item. Let's make a class, and our class will be called, amazingly enough, Minimap. So let's go ahead and bring this in. I don't need any of this, but I do need the Unity engine. So I'm going to bring that one in. Go ahead and dump the first part of this. And I want to make this a public static class. I only want one minimap. And our minimap is going to have to keep track of a few things. So I'm going to define a couple of constants in here. I want an integer constant to hold the padding. This is going to be how far off of the side of the window the minimap's going to be. I want another integer constant to hold the map size. So this will allow us the ability to adjust the size if we choose to. And I also want to be able to adjust our little icon or our little avatar on the map. So we're going to have an avatar size. Now, the size of the graphic that I started off with was 32. So I'll bring this in for now. That's going to present its own little problem. I'm going to have to address that.
Okay.
Now, for this to work, we need a couple of methods. We're going to need a static void start. And we're going to need a public static void on GUI. Now the nice thing is, by doing it this way, and the way in general how I lay out the framework with the inheriting from iDemo, is to make this work, I just go over to my implementation of train demo, go to start, tell it to go minimap.start, and then on GUI, minimap.onGUI. That's all I have to do to wire up the minimap.
Okay.
So that's taken care of. Now, minimap doesn't do anything, and when it starts, I need to load in a couple of images. So I'm going to need to be able to have a place to store those images. So we'll make a private static texture, and we'll call this one the minimap texture. Oops. That's the key I wanted to hit. And we'll make another one, again static, also a texture, and this will be the avatar texture. And no, it's not going to be blue. Alright, so we're going to need to load these up. So minimap texture equals resources dot load, and I believe the file I sent you is labeled minimap.
Correct.
Not minmap, minimap. And then we need to do the avatar texture. Again, same thing. And I'm going to have to fix something too. Dot load. And this one I named icon, just to keep people guessing. So cast that as a texture. Same with this one. Right. Now, next part, we need to draw this. So we're going to go GUI dot draw texture, and new rectangle, and I'll define that here in a sec. And we need to pass it our minimap texture. Now for our rectangle, this is going to rely on our screen width minus our map size minus our padding. And this is our starting X position of our texture. Now with draw texture, it's using 0, 0 as the upper left hand of the screen. And I want our minimap to be positioned in the upper right hand. So I'm getting the upper right hand side of our screen, subtracting the size of our map and our padding size. So I'm subtracting all that. So the minimap will be pushed off of the right side of our screen by our padding in addition to our map size. And then for our Y, I want to push off the top of our screen. So I just have to add, or just tell it that X is going to be padding. Let's go ahead and wrap this to keep it on the same, or on the screen. Then we're going to draw our width and height, both of which are going to be our map size. I can do this because I know for a fact that our texture for our map is square. Your mileage may vary, so if you want a non-square map, you'll have to deal with that separately. Now, if I build this out,
We're going to need to bring these guys in.
if you could for me.
Yep. Let's go ahead and jump these over. Up under textures, resources. And well, there you go. I'll let you make whatever adjustments you need.
All right, now, here's our icon. It's definitely not 1024. So it's 32, and I'll set the point. Hit apply.
Go ahead and switch back to point again.
It dropped it.
And then, there we go.
And for the most part, well, usually anything that's going to be in your GUI, you don't want bitmaps generated for it, and you don't really want it to be filtered. You want it to be a one-to-one relationship. So if I hit apply, that should take our minimap. Is going to be 128. Go go ahead and set this to advanced. No bitmaps. Oh, I'll hit apply. It's just going to throw away the change anyways. Then go to point.
Okay.
All right. Now, hopefully, we should see something.
Let's see where's our character at. Make sure it's, yeah. We'll bring our character back to a more respectable location. And here we go. Hey, there's a little map in the upper right-hand corner. Isn't that cute?
Yep. You know what's remarkable?
What's that?
Is how much Alethea in no way looks like the United Kingdom. To semi-quote a really cool line from a movie.
Look, I mean, it's quite a lot of mountains here. Don't remember my trip to the UK having quite so many mountains.
Yeah, that was my argument, but
I know that. I know that.
but
All right.
mountains are cool. Now,
So we got a 5-pixel offset and a 5-pixel offset up there. So padding a 5 on both. All right, very
yep,
cool.
and that works in 128. The only problem is it's supposed to be a mini map and it's not doing a whole lot. So we need to be able to make our little cute little picture of a map of Alethea actually show us where we're at. So we can start off with drawing our avatar. So that will be our method. So private static void draw avatar. And to draw it, we need to calculate where we're going to draw our position. We can't just automatically go, this is our coordinates. We're going to have to calculate that out, and we have to keep in mind that we've got to translate from our character space into world space, and that world space has to get translated into map space, which then has to be, or the texture space of the real map, and then that's got to be shrunk down to our mini map space. So to keep it simple, let's start off with just one position and we'll grow from there. So our first position, I want to be the center of our mini map. So that is going to rely on calling on a method called map origin. But we don't have a map origin, so we need to create that as well. So we'll go down another private static void, and this one's going to return a vector 2. We're going to call this map origin.
Okay.
But I got to get rid of that void because it's not a private static void, and that returns a vector 2. It's late. Of course, it's always late when we record.
It is.
So now, what are we going to return? Well, we've got to return a vector 2. We already know that, so we need to make a new vector 2. And this is going to be positioned at the screen width minus map size minus padding plus our map size divided by 2. And our y is going to be our padding plus map size divided by 2. So now that I've got my position that's being returned at the map origin, I can do another GUI dot draw texture. Again, another new rectangle. And we'll define that in a sec. And we need to pass to this our avatar texture. Now, our position is going to be position X minus our avatar size divided by 2 by position dot Y minus avatar size divided by 2, and its width and height will be our avatar size. So what we're doing is we're taking the center of the map, our map origin, and then we're offsetting our avatar texture by half of its height and width, so it draws centered on the center of our world. And we'll always want it to be centered on our position, so we'll modify the position that we're sending into. So this will be our avatar size and avatar size. So if I build that out, go over here, and after we draw our mini-map background itself, we draw our avatar. So if we build that out, you should be able to give that a run, and we'll see another problem that we have to deal with. Okay.
Giant grapefruit.
Yeah. Our avatar has eaten the Isle of Man, part of Ireland, part of Britain, and part of Scotland.
Wow.
So it's not a very accurate representation at all of where we're at. But it does show that we are centered up on our mini-map.
Mm-hmm.
So we can go ahead and take our avatar size, and we can shrink it down to, say, something like 4, which was the whole reason we did this. And just for fun, this is not going to look right because of the size of the image that I created, but just to see what happens, let's go ahead and build it out with these numbers and see if our map resizes, maintains its position, and if our avatar comes in the center of that world.
Okay.
I'll cross my fingers and hope.
And we need to give it, there it goes. Hey.
Well, our map is twice as large, and let's see, our avatar is this little bitty dot right here in the center. So kind of hard to see at this size, and it might not be visible at the encoding. So we'll bump up our size just for the video. In our in the demo that we're doing, 4 is the number that we're using, but it might just be too small to see inside of the encoded video. So we'll bump it up. All right. So you want to give that a shot? Make sure it works and it's acceptable.
And there we go. Yeah, I mean, that's fine for this right here.
Well, I just want to make sure that it shows up in the videos.
Oh,
otherwise
you
going...
can see that.
All right. So now, before we get into the next part, we have to solidify something inside of our terrain generifier. Yeah, terrain generator file. I just kind of like concatenated words that I don't think you could really do. But all right, inside of here, when we were experimenting, we kind of hard-coded a number in here. We're still going to hard-code a number in here, but we have to make sure that what we use here is the same number that we're using before or inside of our mini-map. Otherwise, things aren't going to track right. So you
go ahead and explain real quick why that's going to be left as a hard-coded number for now.
Right. The reason we're hard-coding it is because we're not quite sure what resolution the map is going to be. We're not sure how big of the world that we want it to be. And with multiple variables, it gets kind of complicated in going, okay, this is what it's going to be. And
But someone also might wonder, why don't you just take that and put it in a constant then?
we could. And I was leaving it out because I'm always changing it. And when I was experimenting with all of these different variables and the orders of which, it was just easier to have everything here while I was testing and developing it. Once you finalize it, like I mentioned when we were talking about breaking all this out into some sort of other format that's easier for your artist to access, then we could set this up as a more finalized format. But for now, it was just easier to keep it all in one place instead of going, all right, where did I put the constants for that? And then jump up to the constants and then jump down to the method to change the equations and adjust things.
Okay.
So right now, I know that our world is, or our map world is 2048. Tentatively, our world right now is 80,000 units across. That may change. And it changes a lot. This number, every time, this is another reason why I always, I'm just dialing in numbers here by hand, is every time our train patch size changes and our spacing changes, the number of patches that are required to make up the number changes, which gives us another unknown variable to get our overall numbers. So I don't even know. I haven't even run the numbers for it. I know that when I was doing 49 with a spacing of a 3, it was exactly 512 patches. Gave me 72,738 or 73,728 for my world size. And that worked beautifully size-wise. But every time we go up and we change the spacing and the vertices, the numbers that I use to generate this were always changing, which is why it's not an equation. Instead, I just said with the mini map, okay, 80,000 is about the limit of safe size world. So I hard coded this for right now just to test the mini map at 80,000. So our scale is our map size divided by 80,000. And at some point I may go and, tweak this out and change it because I hate hard-coded numbers almost as much as Jason does. But I
Almost.
also almost as much. But I also hate changing stuff and going to the top of files and the bottom of the files and all over the place. Likewise, now that I've got two different places, I'm gonna have to come up with something because now that number is also prevalent in what we're doing next, which is trying to figure out our avatar's position.
Did you change it back, by the way, over in Terrain Generator?
No, I left it there
Okay.
because this is
Mm-hmm.
the equation that I'm going to
Right.
be using, so I'm leaving it there. So now I've got an equation in two spots. Yeah, I know it's really bad, but this is R&D, and I'm sticking with that story.
Okie dokie.
So we need another private static. Again, this is going to return a vector 2, not a void and a vector 2. And we're going to call this one avatar position. Doesn't take anything in, but it will return a new vector. Now we have to calculate this vector. So I'm going to make a var POS, and we're going to get our current characters information from the TP controller instance transform position, and then we have to figure out our scale. So var scale equals 2048. Yes, I'll change this tomorrow. Because yes, it's bugging me too.
Was it 80,000 on the other one?
Yep.
Oh, okay. I thought Could have swore it was 8,000, but yep, it was.
See, making me go all over the place. Backseat programmer.
I'm all right. I'm quiet. Let you
This
do
is
your thing.
pair program. Yeah, I know. And then I screw it up, and then you can laugh at me.
No, I don't laugh at you.
All right, so we're going to export, or we're going to return a new vector 2. Our new vector 2 is going to be made up of position.x times scale by negative position.z times scale. Now, we have to invert our position z because our map is going one way while our world is going the other. So what ends up happening is if you forget to invert positive z, as you start walking towards the positive z axis, you're going to be adding numbers. So I think I can show it from here. So textures, and why am I looking at my screen?
I'm not really sure, to be honest with you, but
I think it's a force of habit. It's like going. But if we look at our mini map, if we're adding positive numbers here, we're going up, which you would expect. But the way our origin is at the center, if we're adding numbers to 0, we're starting to go down
right.
instead of up. So we have to invert it. Left and right works fine, but up and down has to be inverted. That's why we're doing that. So this will return our position. So it's a simple matter of taking our map origin, multiplying it by avatar position, building it, and going, great, we're done. And we can go play with it and realize we're not done. But go ahead, and if you want to give it a go.
Okay.
And this will bring up the next problem. The scale, well, this is running. The reason we're scaling it is the character's position is in world units, which, as we demonstrated, can go out to 40,000 in any direction before things start falling apart. Now, when you do that, our texture isn't 40,000 units in each direction from the origin. It's only a 2048 texture. So what we're doing is we're multiplying it by our scale, so that we're working at the exact same scale. So we're taking world position and scaling it to fit in our 2048 K texture. Now, as you look at the mini map, it may be hard to see, but Jason is currently running north. And according to the mini map, he is running at a really, really fast speed.
Yeah, I've made some serious ground so far.
Right. Now,
Seeing how I
this,
started out more down here.
right. Now, the reason this happens is we scaled the character space or world space into map space based on the 2048K map. Our mini map is not a 2048K map. Our mini map is based off of whatever our map size is. So we're set at 128, which means we have to take our avatar position and we have to, again, adjust its scale or transform it to be mini map space. So we're going to divide by our 2048. I'm going to make this a float just to make sure that we get back a float. And we need to divide by the float of our map size. So we're taking 2048 and we're dividing it by map size, which I think works out to be 16. So I can run it in the calculator just to make sure I'm not completely crazy. So 2048 divided by 128 works out to be 16. So we're taking whatever our avatar position is, dividing it by 16, adding it to our map origin, and that will give us our character's position that has been transformed for map space and then transformed again for mini-map space. So if we build this and we run it again, this yields a very interesting look at how big the world really, really is. Because you can run around the world literally for hours and have fun and think you're going all over the place. But now that we've got the little mini map in place, you realize how little you are really moving. What we're talking
Well,
about
we could just
is,
go ahead and turn around this way
and head south.
and head south.
Yeah, you could. And in about 20 minutes or so, you might hit the Isle of Man.
Yeah, because it's way on down there, even though it looks so close on the mini-map. But go ahead and continue talking while I'm just running along.
Well, what do you want to talk about? It's like on that was pretty much
Yeah,
what I wanted to show, but I mean, this is just the start. I mean, this mini map by all means is very, very crude. It does show you a fairly accurate representation of the world. And Jason and I had this discussion earlier because I had scaled down the mountains so it was closer to the real height map that we were doing. And we were discussing why we're on the mini map. It looked like you were right on the coast, but we were still just coming up out of sea level. And you have to look at the fact that we're taking a 2048K texture and trying to represent it with a 128 pixel map that has been scaled immensely, and we're applying noise to all of that on top. So where on our mini map you would think that there is a one-to-one relation, it's hard to say that, especially when the fact that right now our little avatar on the map is 8 pixels across, and in reality he would be, what is that, about 200th of a fraction of
Yeah,
1 pixel. So even though you may say, oh, I'm right at the coast, you could literally be a couple hundred meters away from it. So when you scale down to that size, it's kind of inaccurate. Now, if anybody out there wants to get real adventuresome, and I'm sure Jason's going to make me do it at some point, is to switch up our little circle avatar with an arrow that actually indicates which way you're facing. That or a compass, even though I think a compass would be
a
easier.
compass would be much easier. But anyways, yeah, that's very nice. So that's pretty much everything that we had planned to show in this video. That gives them at least something basic to play with, Lee.
Yep.
And with that, that is going to wrap up this video. Thanks a lot, guys.